guys, this is Mrs. Foy, and this is the screencast to get you ready to do density problems, all right? Are you ready? Here we go. So what is density? You may have heard of density. You may have even remembered density from working with it when you were in middle school, but density is a double unit. So it's the mass of something per volume, right? The mass of something per volume. So it's a double unit, like miles per hour. So if I look at these pictures, I can see, I could ask anybody, which one of these blocks is more dense? Well, this one, right? So it's more dense compared to the water. So this is more dense compared to the water. This one looks like the density is equal to the water. See how it's kind of floating halfway in this water? More dense than water. And this picture is less dense than water. Less dense than water. Because I can see it's floating. And although buoyancy has other parts of it that come into play, we're just going to be focusing on density, okay? So density is an intrinsic property. That means it doesn't matter how much of it you have, okay? So you could have a little tiny piece of gold and a big hunk of gold, and it would have the same density. So mathematically, density is the mass divided by the volume. And sometimes we say, I heart density, to kind of help you remember that it is the top of that heart stands for mass and the bottom of it stands for volume. So the density of water happens to be 1 gram per cubic centimeter. And because a cubic centimeter equals a milliliter, we could say this is 1 gram per milliliter. Okay, so this is a double unit problem, and we can do a lot of really cool problems with this, math problems with this. All right, so here's our first density problem, okay? What is the density? What is the density? What is the density of a material if it weighs, so let's say we want it in grams per mil, and let's say it weighs 0.75 grams, and we have, let's say we have 1.59 cubic centimeters of it. Okay, so what is the density? So this is a super easy problem, right? But I'm going to show you how to set this up. So you want a double unit. If you want a double unit, you start with a double unit. And clearly, I want the mass on the top and I want the volume on the bottom. All right? And so then I'm going to take my calculator and I'll say 0.75 divided by 1.59 equals 0.471 grams per mil. So I'd be done with that unless my teacher said scientific notation with correct sig figs. This only has 2 sig figs, right? That's the least. This has 3. So my answer is going to have the least sig fig. So I'm going to put this in scientific notation, move the decimal, 4.7 times 10 to the minus 1 grams per mil. All right, so that's the easiest kind of density problem we can do. So another kind of density problem we can do is going to require us to do some factor labeling. All right, so here's a problem. What is the density? What is the density of a material that weighs 150 ounces and has a volume of 9.0 cups? Okay, and I want the density in grams per mil. All right, so I want a double unit. I want grams per mil. So I'm going to start with a double unit. I want the weight on the top, which is 150 ounces, and on the bottom, I want the volume. So now this is going to be a double unit factor label problem. I'm going to get ounces to grams, and I'm going to get cups to milliliters. It doesn't matter if I do the top or the bottom, I'm still going to follow the rules, all right, of factor labeling. So I want the unit on the bottom to be able to cancel. So here I have 16 ounces is equal to a pound, and my ounces cancel, and now I'm in pounds. I need to get to the metric unit here. So 1 pound is 454 grams. My pounds cancel diagonally, and now I have G on the top, which is what I want. So now I got to get from cups to milliliters. This is in the English system, and this is in the metric system. The only English to metric unit that I have on my metric conversion sheet is 946 milliliters is equal to a quart. Okay? So I need to get this English unit to quarts. So I know that there are 4 cups in a quart. 4 cups in a quart, and my cups cancel. And of course, this is on your metric conversion sheet if you don't have that memorized. And now I can use this equivalence and make a conversion factor out of it. 1 quart is equal to 946 milliliters, and I can cancel out my quarts. And so what I have now is I have milliliters on the bottom, and I already had grams on the top, so I'm done. All right? And so if I do the math, what I am going to be multiplying, guys, is I'm going to be multiplying the numbers on the top. I'm going to ignore the ones, and then I'm going to divide by the numbers on the bottom. Very simple arithmetic. So when you do that, you are going to get, and of course I've got, how many sig figs does this have? This has only 2 sig figs, right? Because that 0 is not significant because there's not a decimal. This has 3 sig figs, but this is my weakest link. So when you do the math and you round to 2 sig figs, you get 1.8 grams per milliliter. All right, let's try another one. So the density of lead, all right, so this is a problem where it's giving me the density of lead. The density of lead is equal to 11.3 grams per mil. Wow, that is really dense. And the question says, if I have 3.55 English tons of it, that's a lot, what is my volume in liters? Okay, so this is where I have to use my factor labeling skills, all right? I want a single unit. I want liters. So guys, if you want a single unit, you start with a single unit. And the single unit I'm going to start with is the one I'm given in the problem, 3.55 English tons, okay? Now, I am going to use this density, but not until I get this English tons converted to grams. Then I can use that density, and I'll show you how I'm going to do that. So I'm going to use my metric conversion sheet, and I know that 1 English ton is equal to 2,000 pounds. Okay, cancel out my English tons, and again, you guys should be using that sheet that I gave you, that your teacher gave you. Now I'm in pounds. I'm getting close. Oh, that's right. I know that 1 pound is equal to 454 grams. Pounds cancel. Now I'm in grams. This is exciting. Okay, so now I can use this density right here to get rid of grams. But if I wrote it like this, watch, if I wrote it 11.3 grams per milliliter, do you guys see that my grams are not going to cancel? So what can I do? Well, I'm going to just flip it. Are you allowed to do that? Yes, you are. I'm going to flip the density. So I'm going to put the 11.3 down here. The number stays with the G, right, in 1 milliliter. I took the density and I flipped it. Now my grams cancel, and look, I'm in milliliters. Look over here. I want liters, so I'm just going to say 1,000 milliliters is equal to a liter, and my milliliters cancel. I have canceled all my units, and so now the only thing I have left to do is I'm going to multiply the numbers on the top and divide by the numbers on the bottom. And when you do that, you get the answer of, see, I get 3 sig figs, right? You get the answer of 2.85 times 10 to the 2 liters, okay? So your raw answer would have been 285, right? But if you have to put your answer in scientific notation with correct sig figs, then I would have to move that decimal over, and that's 10 to the 2 liters. All right, let's try another one. Here, I'm going to be given the density of iron. All right, the density of iron is 7.86 grams per mil. And the question says, what is the mass? I want to know the mass in ounces. If I have 35 gallons of iron, okay? So I'm going to start with the unit that I want. You got to set your finish line, guys. I want ounces, right? Ounces is a single unit. So if I want a single unit, I'm going to start with a single unit, and so I'm going to write 35 gallons. Now right now, I might not know what to do, but I'm just going to take a breath and remain calm. I've got gallons. I know that's in the English system. I'm going to look at what other information I have. Do you see mass in there? Right, I see grams. And so I can't use grams because grams is weight, right? This is weight divided by volume, or mass divided by volume. And so I actually want weight. But look at here. Here's volume. And so if I could get gallons to milliliters, then I could use this piece of information. I could use this density. Well, I can do that because I have my metric conversion sheet, and I see that I'm going to need to use 946 milliliters is equal to a quart, because that is the only metric to English conversion I have for volume. So 1 gallon is equal to 4 quarts. And then now I can use this, right? 1 quart is 946 mils. Okay? So now, look, I can use this double unit here to get rid of milliliters. Do I need to flip it? Well, I'm going to see. 7.86 grams per milliliter. I don't have to flip it this time, right? And you don't have to memorize that, guys. You just use your factor labeling skills. So in the last problem, I had to flip the density, but this time I don't. Why? Because the units cancel out this way. So now I'm in grams. Okay, look up at your finish line. I need to get to ounces. Well, I know that's English. I know that's the English system. And so I'm going to have to use my 454 grams is equal to a pound. And then I see in my metric conversion sheet that 1 pound is equal to 16 ounces, right? And my grams cancel and my pounds cancel. And so now what I'm going to do is now I am just going to multiply the numbers. So I've got the numbers because my units all are finished, right? They all cancel out. I ignore the ones. And if you do the math, then you will see, let's see, how many sig figs do I have here? Looks like I've got, the least is 2 sig figs. This guy's 3 sig figs. 3 sig figs. So when I do that, I'm going to end up with my raw answer is 36686, right? So I'm going to move my decimal over 1, 2, 3, 4. So I'm going to have 10 to the 4th. And I'm only going to have 2 sig figs, so I have to round right here. And so my answer is going to be 3.7 times 10 to the 4 ounces. All right? So That's going to get you started with density problems. You have to practice them yourself. You can't just watch this video or watch your teacher in class doing this. You actually have to do the practice problems yourself, right? It's good factor labeling practice. All right, see you in class.